Hi, welcome back to our second example. In this one, we're going to look at the position of terms in Pascal's triangle. A term in Pascal's triangle can be represented by T subscript n of r, where n is the horizontal row number, like we did in the last example, and r is the diagonal row number. So let's go ahead, we'll just write out the triangle first. And you can see I'm lining up each row with the associated row number. Okay, so there is the triangle, and we can see all the row numbers line up. And also remember, we always start with 0 as the first row. So that part is done. Now we want to talk about the diagonals. So another way to represent the entries or the elements that are inside this pattern, we not only need the row number, but we also need to know what diagonal that we're referring to. So those are numbered also, and we use the letter R to represent the diagonal. So R0 would be this row number right here. So I'm just going to represent that using a dashed line. So that's diagonal 0. This one here would be diagonal 1. This one would be diagonal 2, 3, 4, and the last one here would be 6. So all the elements in Pascal's triangle, they could be represented using the letter T. So T n comma R. So the R represents the row number, and R represents the diagonal. So if we're asked to find T of, let's say, 3 comma 1, this means the entry that's in the third row and the first diagonal. So row 3 is here, and the first diagonal is here. So it would be this entry right there, the 3. And that's how we can represent all the elements in Pascal's triangle. Just to show this a little bit further, I'm going to move this out of the way here, and we can write down each element in the triangle using its representation. So T00 would be the first element. That's this one here, because it's a row 0, diagonal 0. The one directly underneath, it's still in the same row, so they're always going to have they're all in the same diagonal, so they're all going to have 0 for the second part of the subscript. The first part represents the row number, and that's what's going to increment. So we'll have T 1 comma 0, and then this one over here would be T also row 1, but this time it's diagonal 1, so it goes 1 1. This entry here, this would be the second row, so T2, it's still diagonal 0. The next one over would be T, still row 2, but this time diagonal 1, and then T row 2, diagonal 2. Okay, once you pause the video, try to do the next row. Okay, so the next row would look like this would be row 3, still diagonal 0. And then we'd have 3 1, 3 1, 3 2, 3 3. So you can see the row will always stay constant all the way through. And then it's just the diagonal that will increment as we go left to right. So for Pascal's triangle, we can say that each term is equal to the sum of the two terms immediately above it, which can be expressed as, so any entry that we're looking for, so T of NR, that's row column, so that is going to be equal to, so if I was looking for, let's say this one, I have to add the two that are directly above. So notice what happens is the row number goes down one. So, and the diagonal is one to the left and the other one is the same. So this would be Tn minus one. That means the row just above. And the diagonal is also moved one over to the left. So it's R minus one. And then the next element would be T, the row just above, and then in the same diagonal. So this is kind of like the formula that you could use to find any element in the array. So right here it says express T of phi 3 plus T of phi 4 as a single term from Pascal's triangle in the form T of n r. So T phi 3 plus T of phi 4. So if you look at it, these elements are actually right beside each other in Pascal's triangle. They're both the fifth row. So this is row 5. And then we have diagonal 3 and 4. So these two, when they add together, they actually add to the one that's directly below. So directly below this has to be in the 6th row. And it's going to be the same diagonal as this one, so it'll also have to be in 4. So we can say that this would be equal to T6, comma 4. Notice that also follows this pattern as well. Okay. So 5 and 5 are like the n minus 1s. And then r minus 1 and r represent 3 and 4. So this would be our T, n of r. Okay, that's it for this video. I'll see you guys in the next example.